In this video, we'll be talking about trigonometric properties. Now, these properties specifically focus on all trig functions and how they behave. The first type of properties we're going to look at are the cofunction properties. Now, in terms of the cofunction properties, they are the ones that actually allow us to manipulate any trig function into its co-trig function based on an angle change. So the first one here is the sine of theta is nothing more than the cosine of theta, but it's not exactly. It's actually going to have a modification so that the cosine is 90 degrees minus theta. So, in reality, I could also have the cosine of theta actually being the same as the sine of 90 degrees minus theta. So these are actually the same function. Sine and cosine actually behave as the same function. The only difference is where the 90 degrees happens to sit. Now, this is also true about tangent and cotangent. It is also true about secant and cosecant. It is also true about again, any manipulation of the co-functions. So the fact that we called them cosine, cosecant, and cotangent, they're not arbitrary. They do have a reason why we call them that. Also note that sometimes we can actually manipulate these so that we're not using degree measures and we're using radian measures. So be very careful on that. Again, these are not all of them. I've just written down the majority of them in terms of sine, cosine, and tangent. Just remember that, again, there's secant and cosecant, and they differ, again, on the interior by 90 degrees minus that theta measure. So that's your first basic property of trigonometric identities and rules. The next thing we're going to move to is the even and odd cases. Now, remember, in terms of even and odd, that's even function if we plug in a negative x and we get back the original function. This one here, again, is even. If, however, we plug in a negative x and we get back a negative of the original function, that function happens to be odd. Now, in regards to all the details in these properties, it's a lot easier to verify and truly understand them based on their graphs, which, yes, we will get to eventually. But for right now, if we're looking at f of negative x equals to f of x, the functions that do this are specifically those that are cosine of theta, as well as secant, its reciprocal. So basically, if I'm looking at these functions, okay, the cosine of a negative theta, so a cosine of, say, negative 45 degrees, is the same thing as the cosine of theta. Again, the cosine of 45 degrees. So at negative 45 and at positive 45 degrees, we actually have the same cosine value. This is also true for secant. So these two functions are the functions that if I replace my interior angle with a negative interior angle, I'm going to actually have the same function. All other trig functions, however, are odd. So the sine function, sine of negative theta, is actually equal to the sine of theta with a negative sitting out front. So for sine, we can take that negative and actually pull it out front. This is also true for cosecant, its reciprocal. This is also true for tangent. And this is also true for cotangent, tangent's reciprocal. So these are properties that, again, we're going to have to make sure we have memorized at some point in another. They are going to come up a lot later, but right now it's just important that you understand that, again, cosine and secant, its reciprocal, are even. Sine, its reciprocal, tangent, and its reciprocal are both considered odd. The next one we already have identified, which I'm just going to simply go ahead and rewrite them, are the reciprocal identities and the quotient identities. Again, remember, for these ones here, it is nothing more than saying that I know sine of theta is equal to 1 over cosecant of theta, given that cosecant of theta is equal to 1 over sine of theta. Okay? Again, if you flip cosecant, you're flipping 1 over sine in response. You can also view cosine as having a reciprocal identity as being 1 over secant of theta, while secant of theta is equal to 1 over cosine. You also have the tangent functions as being 1 over cotangent, and cotangent of theta as being 1 over tangent. Then finally, again, your quotient identities are simply the fact that tangent of theta can be written as sine over cosine, and your cotangent identity can be written as cosine over sine. Again, don't forget, in any of these properties, you must have that theta in there. The last couple pieces that are important are the periods of sine and cosine. Now, if you look to the unit circle, you'll notice that all the values on that unit circle are repetitious. They repeat as we go around the circle. However, they repeat in a certain specific order, and by repeating in that specific order, they cause the functions of all the trigs to have what we call a period, in which case after a certain amount of degree measures, the function itself is going to start repeating. Now, if we look at that, the argument is that sine and cosine, as well as their reciprocal functions, cosecant and secant, all have a period of 2 pi. What that means is that after this function takes one full revolution around the unit circle, it's going to start repeating the exact same values in the exact same order. So sine and cosine have these rules for period, okay, and again the reciprocal functions actually correlate the same exact setup. The period, however, for tangent and cotangent, if you look at the unit circle very carefully, you'll identify the fact that all the values here are considered positive positive. The values coming down this way are negative positive, because again we have a negative cosine but a positive sine. But then when we get to here, you'll notice that it's negative negative, but in a negative negative situation, aren't the values here exactly the same as the value here? And isn't the value here the same as this value here? Such that as I'm crossing this direction and I'm going this direction, if I'm taking tangent, where it's the, again, sine over cosine, the y over x, and I divide them by each other, this value for tangent happens to be the exact same as the value tangent here. And that actually continues all the way through as I map all of those points. So tangent and cotangent actually come from here, hit this location, and then immediately start repeating their values. So the period for tangent and cotangent are actually pi. So a big detail to understand with all of these properties that we've just talked about, okay, for even, odd, for reciprocal, for the periods, all of the sine correlates in one way, so does cosecant. If we look at cosine, all of their correlates to secant in the same way. Same argument for tangent and cotangent. So all of these properties are extremely important for us to remember and for us to have either A, memorized, or B, understood. There's one more set of properties that I believe is the most important, and we briefly recalled these properties before, such that we have a squared plus b squared equals to c squared. If we're looking at this in a unit circle, and again I'll go ahead and draw a triangle right here, I have x, I have y, I have 1. Well, that means that if this is a triangle that's a right triangle, I can change this Pythagorean theorem to x squared plus y squared equals to 1 squared, or 1. But then again, I remember that in the unit circle, x is supposed to be cosine, so I have cosine squared theta, and sine is y, so sine squared theta. And this provides us with our first Pythagorean identity. So anytime that I have cosine squared theta plus sine squared theta, this is going to be equal to 1. Doesn't matter the angle. If I say 45 degrees is my theta measure, then cosine squared of 45 plus sine squared of 45 must be equal to 1. So if this is one identity, we have two others, and we have any, again, algebraic manipulation of this. Now the two others come from the division of this identity. So off to the side here, I'm going to go ahead and take cosine squared theta, I'm going to divide it by cosine squared theta. Now again, I can't do this willy-nilly in any equation or identity. I have to divide everything by cosine squared. So when I do so, you'll notice cosine squared over cosine squared is 1. Sine over cosine is supposed to be tangent, so sine squared over cosine squared is going to be tangent squared. Now again, notice where I'm putting the squared on the trig function, so that it doesn't appear that I have a theta squared. I have tangent squared of theta. And then equal to, now 1 over cosine is again secant, so this is going to be secant squared theta. So that is our second Pythagorean identity, and our third one is simply by taking the original Pythagorean identity and dividing it by sine. In that case, we end up with cotangent squared theta plus 1 equals to cosecant squared theta. And those are the three Pythagorean properties or identities that we're going to have memorized. Again, if you can memorize this one, then you can build these two. You don't necessarily need to memorize those two.